So you have got a working graph system. Basic pipeline is running. Chunk in, answer come out. And the accuracy is okay. 60 to 70% of the accuracy is right. But okay isn't enough. In legal and finance or any situation where wrong answer has a real consequence, okay isn't enough. So how can you go the RAG system that works okay to the RAG system that work really to production or that you can trust? So that is what today is about. 6 advanced techniques, each one targets a specific failure mode, and most importantly, the order you apply them matters. You already know chunking matters, but here's the most important part most people skip: understanding. There are real trade-offs happening with every chunk size decision. Small chunks like 128 to 256 tokens give you very precise retrieval. The answer is probably in there anywhere. But the single sentence without its surrounding context is often meaningless on its own. The model gets a precision but lose understanding. Large chunks like 1024 tokens and above give you a full context. The whole idea is intact. And there's, but now your retrieval vector is representing too many different topics at once. The signal gets diluted. You pull in irrelevant content along with a good start. The medium chunk like 512 to 768 tokens is the most production system length. That is the best balance of the general use. And overlap or a small chunk needed for more fit, around 20% for a small chunk, and large chunk can get like 10%. But here is the honest rule: before you touch anything else, benchmark your chunk size against retrieval hit rate. Most RAG failures trace back to wrong chunk size, not the embedding model, not the LLM, not the chunk size. It is the chunk size. Second technique is re-ranking. So, okay, here is where it gets things gets interesting. You have done your NNN search, approximate nearest neighbor search. You get back the top 50 chunks. You are roughly right, but roughly isn't good enough. The problem is ANNN or approximate nearest neighbor search is that it trades a little accuracy for a lot of speed. It finds approximate nearest neighbors, which means the rank of 50 result isn't the precise as it could be. Re-ranking fixes this problem. You take those 50 candidates and you pass each one, along with the original question, through a cross-encoded model. Unlike the by-encoded used for NNN search with the scores as the question and chunk independently. The score encoded reads them together. It understands the relationship between them. It gives much more accurate for relevance score. Then you re-rank, keep only the top 5. Those 5 goes to the LLM. So like current re-rank and VGE re-ranker are good for ranking. They add about 50 milliseconds of latency, but they routinely improve the retrieval precision by about 15 to 30%. 50 milliseconds, 30% better answer. That is the trade is almost always worthy. Technique 3 is hybrid search. You might be thinking a semantic vector search should find everything. That is right, but meaning over keyword, not always. And here is an example. Someone asks, what does clause 4.2b says about the payment differ? Imagine. A pure semantic search embeds these questions and looks for meaning similarity. But 4.2b is a specific term, right? It is not a concept. It is a specific term. A vector search might completely miss the exact clues and return something gradually related instead. That is where hybrid search comes in. It runs two pipelines simultaneously. BM25, a classic keyword matching, handles exact term, product code, proper name, specific reference. Semantic vector searches handles intent or paragraph conceptual connection questions. Then the result from both gets merged using reciprocal rank fusion, a score method that combines both ranked lists into one final ranking. The result consistency outperform either approach alone by 10 to 20% or mixed type query. Wavelet, Elasticsearch, and Quadrant thus support this hybrid search. Dense handles intent, Spare handles precision. Together they cover each one's blind spots completely. The technique for it is metadata filtering, right? No, here is one that is incredibly powerful and genuinely understood. Every chunk in your vector store has metadata attached. Source file, date, department, document, type, author, and section title. Metadata filtering lets you use these attributes to narrow the search before or after NNN or approximate nearest neighbor search runs. Say someone asks a question that should only be answered from the document published in the last 90 days. Without metadata filtering, the system searches and might return 3 years old policies that have been superseded. With a data filter, only recent document gets searched. So style result disappear completely, no model change needed. There are two approaches in metadata filtering: pre-filter and post-filter. Pre-filter means apply a metadata filter first, run NNN, or before you run approximate nearest neighbors search on only the matching subset. So fast, it is faster, but you might miss relevant documents if you filter too strict. Post filtering means run after approximate nearest neighbor search. Then the filter results better recall and slightly slower in this case. And for multi-talent systems, like where different users should only see their own organized data, metadata filtering is not optional. It is the only safe way to enforce data boundaries without building a separate index for every claim. Technique 5 is query rewriting. Here is a problem. Nobody even talks enough about it. Most users ask a terrible question. Even me, I ask terrible question for LLMs, and because it is not because of they are not smart or we are not smart. It is because of we are typing quickly. Fix login issues, summarize questions, what Einsteins do, short, big, and context-free questions. and short vague queries produce poor retrieval in a RAG system. The embedding doesn't have enough information to find the right chunks. So query rewriting fixes this before the question even reaches to the retrieval. An LLM interprets the original question, expand it, adding synonym, adding context, domain context, temporal scope, and rewrite it into something that matches more retrieval friendly. Fixed login issue becomes an auto token expiration casing login failure in the web application authentication flow. What Einstein's do becomes key specific contribute of Albert Einstein in physics in 1905 to 1955. The sixth technique is multi-query retrieval. Okay, this is the last technique and is one of the elegant, right? The problem in single query, no matter how well written, might miss relevant chunks that are phrased differently in your document. One angle of question retrieves one set of chunks, but a complex question has multiple angles. Multi-query retrieval handles this by generating 3 to 5 semantically distinct versions of original questions. Each variant runs on its own independent retrieval. Then all those results get duplicated, merged into one unified context set before going to LLM. So instead of one search with one angle, you are running 3 to 5 searches simultaneously, each one targeting different ways. The answer might be phrased in your document. So what are the side effects of Abu perfume might generate variant like a perfume adverse reaction, or it risks overtaking it, or it may answer like NICID gasostotrian effect. Each one surface different chunks together much higher record. Long chain multi-query retrieval and the lemma index sub question query engine both implement this. It consistently outperforms a single query retrieval on complex and multi-faceted questions. So the 6 questions. But here the most important thing I want you to take away. These are not alternatives. You don't pick one. You learn them, and the order you apply them matters enormously. Start with chunk size and overlap. This is your foundation. Fix this first. Benchmark retrieval hit rate. Fit it under 70%, and nothing else will give you. Then hybrid search, BM25 plus vector. Fused with RRF, this is immediately handles the gap between semantic and exact matched queries. Then add re-ranking. A cross encoder on your top candidates, precision jumps without touching your index. Then you can add a metadata filtering, especially if you have a data sensitive content or multi-talented requirements. Then you can add query rewriting, and then multi-query rewriting also will be good. Each layer addresses different failure mode. As we can see, each one stacks on top of a previous. Apply them in wrong order, it will give you wrong answer or wrong system. But if you apply them in the right order, it will give you right system. So 60% of the accurate system to something you can actually trust in production is just applying those techniques in order as I showed you. That is advanced drug. No magic, just the right technique applied in the right sentence. It is not a rocket science, so it is easy, easy. So thank you very much. This was about the 6 most important techniques in a rack system and their mode failure of mode. So thank you for very much for watching this video, and if you like it, please hit that subscribe like button and subscribe for next. And the next video I will show you how to create a rack system using N8N or other mode. Most probably N8N. We will go with N8N for showing how it works from basic to advanced. We will build. So make sure that you subscribe and don't miss it. Thank you very much.